All right, in part two of visual tools, we'll be taking a look at Pareto charts. This is an extension of the visual tools video, and I encourage you to go back and review part one, which includes a discussion about dot plots, box whisker, and comparing them to histograms. But now let's take a look at Pareto charts. Okay, I pulled up a new data set. This is from the data files folder. It's called Pareto, and obviously, it's data that we use to help create another type of visual display called a Pareto chart. Pareto charts contain bars, so they look sometimes similar to histograms, but they are in no way similar to histogramming. Pareto is actually just rank sort ordering of data where you take a look at a phenomena, let's say defects or mistakes, and you rank it from smallest to largest, or I'm sorry, from largest to smallest as a bar chart. And then that allows you to identify either the biggest impactors or the least impacting and make decisions moving forward on what to do. It's a rank sort ordering technique, bar chart. Let's take a look at a Pareto chart. And I think what I'll do is let's use this circuit board defect data. It's pretty simple here. We've got different types of defects. And, I could quickly eyeball this given that there's only about 10, 15 values and see that it looks like the TH void is the biggest defect type. But this is unsorted data, defect data. I'm going to highlight it and I'm going to create a Pareto chart to better understand I'm going to highlight it and choose Pareto chart to get a better understanding of what defect type is creating our biggest pain points here. So go to QI macros and go over to the Pareto chart menu and press OK. There you go. That's it. Shows the largest one at 16 TH void, and then it shows the relative impact of all of the others. Note that once you get up to 9 different subcategory types, it'll combine all of the remaining ones into something called an other category. You can go back and change that, change it from 9 to 15, 9 to 5. It's up to you how many subcategory types you want displayed, and then the rest showing up in others. Now, what Pareto charts don't show you are central tendency and spread. They're a way at understanding biggest to smallest. It is not a central tendency and spread tool like histograms, dot plots, or box whisker diagrams, but it is a visual tool that is frequently used in continuous improvement. We sometimes call it the 80-20 rule, where we're trying to understand the items that contribute to 80. Is there a small grouping of values that contribute to a large amount of the process pain point phenomena that we're looking at? Another aspect of Pareto chart is that in addition to these rank sort ordered bars, we will sometimes create this cumulative percent total, where if we were to add up the percentage of each one of these occurrences, all of them together would add up to 100%, and the relative amount for each grouping is displayed here. 25, the two together for TH void and insult add up to 40. The three together, if we include bad, add up to 55, and so on. I sometimes find that this cum percent total line is a little confusing for folks that are viewing the chart. So I will, on occasion, what I'll do is I'll highlight it and just delete that cum percent total line so that we just have a simple rank sort ordering of bars. But a classic Pareto chart would include that cum percent total. So we've taken a look at a number of visual tools, histograms, box whisker diagrams, dot plots, and Pareto. The first three are used to better understand central tendency and spread. The last one, Pareto, is used to just help better understand rank sort ordered data. And they're powerful tools for data analysis.